Today. Those of us who have taken statistics, you've heard of the PDF. Yes? You're like, scrum. All that is it's a function. You're right. It's called a probability. Probability density function. Okay? Now, can you... Now, here's the dealio. It is some random function such that when you integrate it from a to b is equal to 1. If that's true, then you have yourself a PDF. It's important that it equals 1 because why? Because of 100% probability. That's right. By the way, when you integrate it like this, so f of x is the PDF, and when you integrate it from a to b, that makes it a CDF. What? That is a cumulative density function is the actual integral. Okay? So in statistics, we use PDF and CDF all the time. Now, can you give us an example? Yes, please. So 1 over x dx. Let's do this one. It makes me happy. Let's integrate it from 1 to some value a. Okay. Now, listen, friends. I would like to find out what would a have to be to get a 1. In other words, I'd like to know what would a have to be. I don't know. Let's find out. What is the antiderivative of 1 over x? Somebody? ln of x from 1 to a. Well, Mr. Groom, wouldn't that just be the ln of a minus the ln of 1, which I don't need print, but I did anyways. Whatevs. Get over yourself. No, and it's supposed to equal what? Better equal 1. What is the ln of 1? It's a goose egg. That's right. Dude, how do we solve for a here, yo? Exponentiate. You get the prize, yo. So, 1 over x, which is this function right here, from 1 to e, from right here to here, that is a PDF. So then there will be a follow-up question. What's the probability that you get a number between 1 and 2, Mr. Groom? I don't know. But I know what I would do. I would take the integral of 1 over x, because that's our function, and go from 1 to 2. And it would literally be this. ln of 2 minus ln of 1. Oh my gosh, this is still 0. This is 0.69. Mr. Groom, how do you know that? Because I'm weird. 0.69. There's a 69% chance of that happening. Is it? Is it? Can you do a harder one? Well, yeah. 1 moment, please. 1 moment, please. Because I'm happy. I'm happy it's Friday. Oh, Levi, did you see this yesterday? This was for you.
Me?
This is for you yesterday, dog.
What's the problem? What was yesterday? Boom. That's what I'm talking about.
It's just, what's that? Yeah.
Yeah, brother.
Yeah, man. Hey, 1 over x squared plus 1. Mr. Groom, I feel like that looks like this. I feel like you're right. Those of us in stats go, hey, that looks like the normal. It does, but it's not. It does look like the normal, but it's not. But, what if I wanted to integrate from here to there? Oh, my word. What does that mean? What does that give us? It's improper integral, dog. So what do I have to do? Split it and go from negative infinity to 0. Probably that's what I would do, but you do what you want to do. I'm not going to judge. I'll probably judge a little bit. From 0 to infinity, I like 0. It's a cool number. What's the inverse? What's the integral of 1 over x squared plus 1? Arctan of x. That's q plus arctan. Ah! Why did I put a 1 there? Because I'm an idiot. I don't know. That's probably it. All right, friends. What is the arctangent of 0? I don't know. Minus the arctangent. Oh, minus the limit. As x goes to negative infinity of x. Well, of the arctangent. Try again. Of the arctangent of x. Yes? And so what is this approaching? Well, arctangent, Mr. Grimm, I don't know what it looks like. Let's go ask the great Googly Moogly. We'll see what she says. Oh, Desmos, where art thou? I might be high. That is just weird. There we go. Say, what's happening as you head towards infinity? What is it approaching? 0. It is headed towards 0. That's correct. So this is, so let's see here. So, oh, that was arctangent. So let's back it up. Let's actually graph arctangent, Mr. Grimm. If you graph the right function, it might work, stupid. That's what I meant to do. And what is it approaching as you head that way? It's approaching pi over 2. Negative pi over 2, isn't it? Okay? So that's negative pi over 2 on this side. Why is this a minus? That should be a plus. Oh, that's a minus there. That's a minus, but Mr. Grimm will get it right. So I'm doing just this portion here right now. So minus 0. Oops. Try it again, stupid. 0 minus a minus pi over 2. There we go. There we go. And we're pretty confident about this one. This part here must be pi over 2, right? And what happens when you get pi over 2 plus pi over 2? You get pi. So my question to you is this. Because this equals pi, is it a PDF? No, it has to equal 1. How are you going to make it be 1 instead of pi? Well, you could put a 1 over pi out front, couldn't you? Right? And then it would equal what? 1. So friends, this thing right here is a PDF. On your assignment, they will do a lot of things like, can you find an A to put out front that would make it a PDF? Yes. How? Take the integral, and when you're done, if it's not 1, divide by whatever, or multiply by 1 over whatever it is. Is there any Kleenex on my desk? Philip, you see any? Is it all gone? Can you go fetch us up some? Because I'm having a mess. Thank you. Woo! All righty. Well, then the question then, of course, is, well, Mr. Grimm, what's the probability that you're between negative 2 and positive 4 on this problem? Well, I don't know. But I do know that it would be 1 over pi from negative 2 to 4. 1 over, what are you doing, man? You done? You need that? All right. Q, what?
For the traces,
Yep.
it doesn't matter what values.
I don't really care. Just pick 4.
Okay.
Yep. Mm-hmm. So, well, Mr. Grimm, isn't this going to be 1 over pi arctan 4 minus arctan 2? Literally, that's what it's going to be. Okay? This is not hard, people. This is not hard. I'm going to steal these Kleenex. All right, where we at? So we got it. What did you get for an answer? I don't know. I'm dying to know. Who's got a calculator? Get a calculator. Let's do it. Like you say, M&M. You hate them. That's what you said.
Yeah, no, it's fine. Backs me up.
1.325 minus negative 2. 2.43. Is that what I got? Divide by What? 77%. There's a 77% chance of that happening. Ta-da! If you get a number bigger than 1, you screwed up. That's got to be up here too. Now, let's do another, shall we? Now, I know what Hainsey's thinking. He's like, Mr. Grimm, what does the normal distribution look like? Can you show us that? Love to. It looks something like this. How do you not know? Because I don't do it this way very often, so I don't really care. What's up, dog? How are you?
Good.
Oh, I was talking to Layla, but yeah, it's good for you to see you too. What do you got in the bag there, bro?
None for you.
Hey, hey. I miss you, dude. We were sad you were late today. It made me sad. I cried a little bit. I know. That's all that counts. I know. You too. Is that one squared? I think it's that one squared. Mr. Grimm, I don't know what that crap is. Listen, friends. You've heard of the normal distribution, yes? It looks like this bell-shaped curve where that's the mean. And sigma squared is the standard, or sigma is the standard deviation. Yeah. And it goes from negative infinity to infinity. And I'm pretty positive I did it right. I'm 99% sure I did it right. I don't really care, but I'm 99% confident. Here's the deal. How would you antiderivatate that guy? Well, very carefully is what you'd do. I want to say there's a square up here. Is there a square up there? There must be a square up here because you can't antiderivatate this. There has no antiderivative in closed form. There isn't one. And what happens then is this, friends. It looks like this. Oops. What? When you graph it, it looks like this, where the mean's right in the middle, huh? Nice. And when you integrate this sucker from infinity to negative infinity like that, oops, doesn't equal negative 1, equals 1. That's right. And so if you go, Mr. Grimm, suppose I go from, like the average weight's 110 pounds or whatever. Suppose I integrate from 100 pounds to 120 pounds. Ooh, Mr. Grimm, isn't that exciting? It's 68%. What? Because it's one standard deviation away, which we know from stats, but the rest of us are like, what are you talking about? It's not important. Okay? Suffice it to say that in your calculator, a lot of you have never used it. In the stats functions, there's a normal PDF there, and then there's a normal CDF. And the normal CDF is basically just doing an integral for you. And you're just like, dude, that's cool. Now, for today, that's not what we're going to be doing. They're going to hand you a PDF like this. Here's a function. Actually, Lacey, give me a function. No, pick your favorite number. Single digit, go. I knew she was going to say that. X to the, pick your favorite number, Jacob. I was going with this, Jacob, but you're right, Olson. I literally could not think of his last name for 2 seconds. I was like having a brain fart. Go ahead. 2 plus
3.
Oh, I didn't realize that's where you're going.
minus Hallie. Awesome. That looks fun. That looks fun. I want to do it. So friends, what I'd like to do is I'd like to turn this into a PDF on an interval from 0 to somewhere. What's the somewhere? Well, I don't know. I don't know. So let's do this thing. So this is one thing that they'll ask you about today on your homework, something like this. So first things first, let's antiderivatate. And that's going to be, what, 2/3 times 8, so 16/3, x to the 3/2, right? And go from 0 to a. So plug your a in, so plug your a in at the top, plug your 0 in at the bottom, and this thing needs to equal 1 when you're done. Mr. Grimm, that's going to be 7a cubed over 3. how am I supposed to solve this? Well, how would you solve it? Everybody but Lacey had Mr. Patterson for a teacher last year. How would you solve it in Patterson's class? I would too. That's right. I think so too. So, Mr. Grimm, how would I do it? Well, I would take this thing right here, put that into Desmos, yes? I put y equals 1 into Desmos. And they would cross each other, would they not? Do it now. I'm going to go over here and write a thing down for him.
Okay. I'm on number 6.
Peter?
Right? So, but then you try to do that. That's your plan.
Yep. What? How are we getting this on one line?
Right, so then I'm but then you actually plug in, right there. But then when you actually plug in the original, you get to that. So that's all kind of block.
Explain why. Like, explain me why.
Same thing. So it's only if this value is
Yeah,
Oh,
I mean,
by the way,
clearly if you're,
16 on.
clearly if you're approximating the plan, all right. Oh, yeah, always in ratings, people.
Yeah, I don't know why I was looking at.
Always, always, always.
Yeah, no.
Always, always, always.
That's something that we-
Always, always. Always, always. All right, get it? What'd you get? 1.231. Do you agree, Hallie? Listen, Mr. Groom, I don't know. I don't know if I trust you, Mr. Groom. I don't either. Shh, let's do it. What is the problem? So is it 7/3? What was the antiderivative?
Oh, 7x cubed over 3.
Whatevs. Let's just check it out, dog. Then what?
Plus 3x to the 14 over 14.
Who came up with that stupid one? That's ridiculous.
And the next one?
16/3.
Yeah. So 3x.
What?
How did I enter this in wrong?
I don't know. Is that what you got? 1.2? Did you get 1.2? What's that? Oh, I didn't. Oh, I'm sorry. I didn't put the y equals 1 in. What a moron. 1.23?
Not too far off.
Hi, kid. Nice job. 1.23. What you got? Because listen, that's where they listen. Look at it. This is where you need to find a value of x, or a in this case, yes, where it equals, where that thing equals 1, yes? And where does it equal it? Right there. What if it crossed it more than one time? How would I know which one to use? What? What's that? Well, yeah, oh, for sure, for sure. If it was over here, we wouldn't use this one, right? Because we went from 0 that way, right? If there was 2 of them over here, first one, yeah? The first one, not the second one. I don't know. I just work here. I don't know. Minus 16 times, right? Yeah. There you go. Yeah?
Yeah.
Nice. All right. Let's do another. Let's do another, all right? Now, this is about as hard as they're going to get, Hallie. This one's the trickiest one. Mr. Groom, I would like to know what value of a you would stick here. So that when you integrate from 2 to 15 of this function. Ooh, this will be a fun one. See if the kids are paying attention. Yes. Plus 6 Yes, here we go. Yeah. No. Mr. Chrome, you're a horrible person. Yes, I am. So, you're like, oh, all I gotta do is take the antiderivative. Yeah, that's the hard part, ain't it? How you gonna do that from this one? Integration by parts. Right? And what would it be? So you let u equal x, and dv equals e to the x. This is a nice little review, is all. Right? And it's uv minus the antiderivative of e to the x dx. So x, e to the x, minus e to the x. That's the first part. Right? That's this guy right here. How do I do this guy? What is that thing? What do you got to use to do that one? Oh yeah, I feel like there's a function in a function. So what method? Substitution. Were you afraid to say it out loud?
No, I didn't think of it. I was like, oh.
That's how I feel when I look at kids and I go, what's that kid's name? Angel, I've never forgotten your name. That's good. Oh yeah, he's never but
That too?
yeah. Equals z. All right, so where was that? Oh, back here. No. What?
Oh, never mind. You know what?
What?
I figured it out. It's cool.
Hey, yo, so u is this, right? So du is 3 dx. So I have a third of a du, is that right? So I have 6 over 3, right? Because I have a third of a u, du. U to the fourth du. So that's 2. That's u to the fifth over 5. So I have this portion of the problem over here. Plus, is it plus or minus? Plus 2/5. What was it? 3x minus 7 to the fifth, right? And I integrated from 2 to 15. Say. And when I'm done, I need to multiply it by some value of a, yes? So that the answer is equal to 1. One could see that in a moment this is going to be a number. Call it 100, I don't care. How do you solve for a? You can divide by that to the other side. Whoopee! Let's make it happen. So, plug that in. That's going to be a mess. I'm too lazy. Let's just type it in, shall we? So it was x e to the x. Did you not write it down? Was I too fast? X e to the x minus e to the x plus
2/5, 3x minus 7.
ah. What? Cool. Now, ooh, you know what I should have done? Since I'm in Desmos after all. Oops. I'm just feeling lazy. Just feeling lazy. So what I want to go from where to 2? Is that right? So 6.989, write that down. And that mess. 77460310. All right, go ahead and write that down.
No decimal number.
Yeah, well, 0310.4146 minus, what was the other one? 99989. Cool, there's my number right there. So it's 1 over 7746.0303.4256. That's cool. That's cool. And when you do 1 divided by that, you get, oops, oh, fart. Well, we can do it that way too. Screw you. We'll do it this way. To the minus 1. And that, friends, is why we learn pre-calculus. So 1.29 e minus 8. That's a disturbing problem. Will that be that gross on the homework? No. They will not be. But if they were, do it. Why not? So up here, Hannah, that just means that this right here, sister, 1.28, no, what did I say, 29? If you integrate that sucker over its domain, you will get 1. Period. And so Hannah, part B of this problem will say something like this. What's the probability that you get an x between 12 and 15, Mr. Groom? Okay? Well, you literally put a 12 there and integrate it again, don't you? I don't have to really do the integrations again, because couldn't I just come down and do that? Yes? Because you know A, right? You know what that is, but you don't know what it equals now, do you? Plug it in. It's a beautiful thing. Now, for those of us that are in statistics, remember Mr. Groom mentioning that it didn't matter if we include those or not? Why not? Because what happens when you integrate from A to A? You're trying to find the area of a line. And there's no such animal, is there? So whether it's here or not there, makes no difference. Okay? That's cool. What's up? Oh, one of those. One of these stupid pens. I'm going to break it. 12. Maybe not. Maybe I have learned some finesse. Probably not. That would be horrible. What a nasty person you are. That's mean. Yeah, don't do that. That's a plus. I didn't hit shift hard enough. There you go. All right. Ready? All right, last one. I'm not going to help you. You do it yourself. So look, A, we're going to integrate from 1 to 7. Are you just going to pick some nice, easy ones this time? Kinda. No, we're not going to do E. That's mean. X squared, sure, plus 3e to the 2x or something. That's kind of gross. Let's don't do 2x. 3e to the 0.1x. I like that. That's more better. Plus 2. So we want to find A, and A is going to be gross. I don't know what it is, but it's going to be gross. Fact. And part B, I want you to find the probability. By the way, if I said probability from 0 to 3, would that bother you? Yes, because it has to be between 1 and 7, yes? Right? There is no other probability for this probability distribution. It only works from 1 to 7. So if I said to you, this probability is, from like 5 to infinity. I don't know, because it can only go from 5 to 7. That's weird. Okay? So keep that in mind. So I'm just going to go from, let's say, 3 to 4. Ooh, a nice small region. Okay. That's cool. All right, do that. I'm going to wander around and make fun of these guys for a few minutes. What's up? Down in the original problem to find the original value, yes, which is that. But what would you get prediction for? Would you get that for a prediction? Well, right. My bad, I didn't think that through. But listen, so if you use me 4 down 1, did it ever change? So it wouldn't be a great predictor.
Like, not at all. Crazy thing.
basically what he does most of the game. That's what I do. Just put it in A or a slider of some sort.
Yeah, bro.
That's what I do. That's what I would do. You're right here. The actual value is here, right? This but it's actually that. How far? Yeah.
Do you care about the X, Y, then too?
All I care about is the Z, bro.
Whoa.
Here, watch. I'm Richard.
Hashtag bring Richard back. I know.
Oh, hey, go grab those. Grab those ballparks. I want to see they turn out. I've seen that time to do it.
Yeah, sure. I'll do that.
Oh yeah. So, all of you vector sector people, I sent you
I got that.
thing. I want you to try graphing one of those today in Desmos for you. I just want to see if I want to do that for another class.
How do you do piece wise on this?
So,
Isn't that a way?
yeah, so use R squared, yeah, whatever. So type in whatever it is. And then when you're done, when you got where you want to do it, not like that, not like that, back up. So it's like 3 theta, right? And then squiggly brackets. And then theta, or negative 3, less than theta, less than 2, or whatever. And then do another one next one. The next one,
Oh, there's no way to, isn't there a way in Desmos to just type it in? There's a way.
I wouldn't. What? Oh, man.
I know that there is a way to start moving this. Really good. Really good and good.
Yeah, just keep writing.
You can't hurt me. I'm all over this. Did you get her? What'd you get? What'd you get done? You got an answer?
Yeah, I got 2.07 times 10 to the negative.
Heck was it?
It feels big. I don't know. Let's feels big, but let's try it. So would this not be 4x cubicled over 3? Right? And then
Oh, that's
plus
just A.
30. No, I'm just asking. 30 times 0.1 to the x, right? Because you got to divide by the 0.1, right? Plus 2x. From 1 to 7. Literally, I don't know the answer to this. But that is the right antiderivative, right? So write that down, and then we'll go and we'll plug a value in. So we know this needs to equal 1. And so, what did I say it was? I forget what I said. So 4x cubed over 3. And then what? 30 e to the 0.1. And then what? Plus 2x. And I don't want to do that. Why did I use x? Why are you so dumb, Jay? Stop it. And where are we going from? So 1 is 36.48. 7 is 531.75. Right? What do you get when you minus those guys? I don't have a calculator. 531.75 minus 495.25. Bam. So listen. So this is A. So this is 495.25. A equal 1. So A is 1 over 495.25. Okay, that's it.
I did something. I didn't put 2A, I just put plus 2. That'll change it.
Just a little bit. Just a little bit. There we go, right? Then I want between 3 and 4. So literally, all I must do
Oh, doesn't matter if the A is
is come down here and put what? Right? I already have this freaking thing on my calculator. So come back over here, make it say 3, 82 and a half. Jot that down, 82 and a half. 138 for the other one. So what is 138 minus 82 and a half? 55.59. So this inner portion here is 55.9? 59, whatever. Divide by 495.25. And that comes out to be point. By the way, if it doesn't come out to be a point, again, you screwed up. It's a percentage. It has to be. It's a whole bit. About 11%. Whabs. See? It cannot get easier than that. That's all there is. I can only ask you to find, can you find this missing term out front? Or could you, wherever it went, could you do a deal where you have to find, no, yeah, find one of them guys. Maybe. That's all I can ask you about. And then when you find one of those missing pieces, then I just ask you to find probability between here and here. Just integrate. And the best part is you've already done the antiderivative, right? Just evaluated at different points. Ta-da!
on a test you can expect it to show where
No. It's a count. Just crunch it out. Done. Done. Hilarious. This teaching 251 right now at PC at OIT, and this guy says to me, "Hey, I found a better way to do derivatives. Have you ever heard of the power rule?" Yeah. We're gonna learn next week. Why didn't you show us